So hello everyone, this is Tusar and you are watching chem-ignitor. So in this video lectures, we are going to discuss about the integrated rate equation for zero order reactions and also half-life, and also we are going to discuss various characteristics of zero order reaction. First is integrated rate equation for zero order reaction. Or we can say the kinetics for zero order reactions. So what is zero order reaction? Let me define what is zero order reaction. Zero order reaction is such kind of reactions in which rate of the reaction doesn't depends upon the initial concentration of reactant. आमे जानी छे जे कोनोसी रिएक्शन नो रेट ता तार concentration नो reactant ऊपर डिपेंड करे, but in zero order reactions it is a very peculiar reactions in which rate of the reaction doesn't depends upon initial concentration of reactants. So it may be defined as the reaction in which the rate of reaction is independent upon the concentration of the reactant is called zero order reaction. The reaction in which the rate of the reaction ROR is independent upon the concentration of reactant is called zero order reaction. Zero order reaction. We know that in 99% cases the rate of reaction depends upon the concentration of reactant, but in case of zero order reaction the rate of reaction doesn't depends upon the concentration of reactants. So for example, H2 plus Cl2 in presence of sunlight, that is H nu, it gives 2HCl. Here rate of the reaction ROR, rate of the reaction equal to small r equal to K into H2 Cl2 to the power 0. This is the rate law expression. This is the rate law expression. This is the rate law expressions. Here rate is independent upon the concentration of reactant. H2 to the power 0, this will become 1. Cl2 to the power 0, this will become 1. So ROR equal to K. Here K is a constant, that is rate constant or velocity constant or specific reaction rate. Here rate of reaction equal to K. That means rate of the reaction doesn't depends upon the concentration of reactant. Rate of reaction is equal to K, that indicates the rate of the reaction doesn't depends upon the concentration of reactant. Hence, the reaction between hydrogen and chlorine in presence of sunlight is a zero order reaction. So, let me derive the integrated rate equation for zero order reactions. Now, the derivation. derivation of zero order kinetics. Derivation of zero order kinetics. Here, suppose A gives rise to product be the chemical reaction, be the chemical reaction. Be the chemical reactions. So at time equal to 0, let at time t equal to 0, let at time t equal to 0, the concentration of A is A naught. At time t, this concentration, we know the concentration of reactant gradually decreases. The initial concentration is A naught, because at time 0 the reactant is not started, so the concentration is A naught. At a time t, at a particular time t, whatever it may be, at time t, the concentration of A naught suppose decreases to A. At time t, the concentration of initial concentration A naught suppose changes or decreases to A. At time t equal to 0, A naught is the initial concentration of reactant. At that time, the concentration of product is 0. At time 0 means reaction start हैनी. Time 0 माने reaction start हैनी. हमें नहीं थले A naught concentration, product हमें पहले 0. At time t, concentration A naught decrease है ची A को. A naught टा decrease है A ही जाए ची. हमें नहीं थले A naught, but कमी A ही जाए ची. ताले formation के ते ही दिखो product A naught minus A. Here at time t, the concentration of product equal to A naught minus A. Here A naught is the initial concentration of A is the final concentration of A. That is, A naught is the initial concentration of reactant, A is the final concentration of reactant. Here 0 is the initial concentration of product. Initial concentration means time 0 re reaction start हैनी, product formation केमती होगा. So product concentration 0 अछि. At time t, the concentration of product is A naught minus A. A naught थिला एबे बर्तन remaining अछि A, so formation हेइथो A naught minus A. This is the model for zero order reactions. Now we have to derive the equations. We know for zero order reaction, rate of the reaction is equal to, is directly proportional to A to the power 0, because we know rate of the reaction doesn't depends upon the concentration of reactant. So for zero order reaction, the power of A should be 0. So rate of reaction is directly proportional to A to the power 0. Now here we can write the rate of reaction as minus dA by dt. In terms of reactant, we can write the rate of reaction as minus dA by dt. Minus dA by dt proportional to A to the power 0 implies minus dA by dt equal to k to the power 0. Minus dA by dt equal to k a to the power 0. Here लिखे पड़ो this equation will become implies minus dA by dt equal to k minus dA by dt equal to k. So something to the power 0 is 1, so minus dA by dt will become k, implies minus dA equal to k dt, minus dA equal to k dt, dA equal to minus k dt, implies dA equal to minus k dt, dA equal to minus k dt. We have to integrate these equations. So now integrating both the sides, this equation will become integration dA equal to minus k dt, constant or integration is not possible, so minus k integration of dt, integration of dA, integration of dx is x, integration of dt is d, integration of dy is y, so integration of dA becomes a equal to minus k as it is, integration of dt will become t minus kt plus c. We have to add c here. Here c is the integrating constant, where we have to write it as, here c is the integrating constant, because this is the indefinite integral, we have to add some integrating constants, where c indicates here integrating constant. So here c is the integrating constant, here c is the integrating constant, whose value can be determined by taking some conditions. हमारा reaction कौन थिला, our reaction थिला A gives rise to product. मु बुझाय पई कहू जे एटा आउथरे अगेन लिखिया दरकार नै, at t equal to 0 concentration थिला A naught, product रो concentration थिला 0, at a time t reactant रो concentration थिला A, product नै थिले A naught minus A, product नै थिले A naught minus A. This was the model for zero order reactions. एतिक थिला हमर इक्वेशन. तो एडी कोन हबो, हमें जानि जे at time t equal to 0 A equal to A naught, जेतले टाइम 0 जेतले रिएक्शन स्टार्ट हेइ नथला, इनिशियल कंसंट्रेशन जहा थिला फाइनल कंसंट्रेशन भी से रिएक्शन स्टार्ट हेइ माने स्टार्ट हेइनी माने इनिशियल कंसंट्रेशन जहा फाइनल कंसंट्रेशन भी से, सो at t equal to 0 A becomes equal to A naught. At t equal to 0 comma A equal to A naught. This is the equation 1. Putting these values, we can write here, putting these value in equation 1. हमें जदी t equal to 0 और a पई a naught put करिया equation 1 रे, तले equation 1 को हो, the equation 1 will become a equal to a naught a टा कोन हिजबो a naught हिजबो t टा 0 होबो a पई a naught पकेबा minus k into t by पकेबा 0 plus c as it is रहिला so c रो वैल्यू कोन हिजबो ना a naught हिजबो c रो वैल्यू हिजबो a naught implies c will become a naught. Now the putting the value of c equal to a naught again in equation 1 we have a equal to we can write here putting the value of c putting the value of c in equation 1 we have a equal to minus kt plus a naught a equal to minus kt plus a naught. Here if we plot a graph between a versus t then the nature of graph will be like this. So let me plot the graph now. So comparing this equation with equation of straight line that is y equal to mx plus c हम जदी ए इक्वेशन को y equal to mx plus c सहित कंपेयर करिबा ए इक्वेशन को जदी y equal to mx plus c सहित कंपेयर करिबा a को नबा हमें y एक्सिस रे हमें ए x को नबा t को नै जबा x एक्सिस रे सो x रो कोएफिशिएंट जे सी होची m here m is the slope so here minus k will be the slope and here c is a naught so we can write here comparing this equation with y equal to mx plus c we have the following graph. The graph is here the graph is a versus t. We have to plot a versus t. Here t is time, a is concentration of reactant. Here the slope is minus k. Since the slope is negative, the nature of graph will be like this. Here a naught is the y-intercept. This point is y-intercept means y-intercept c is the y-intercept. Here a naught is the y-intercept. Y-intercept ର अर्थ होची लाइन टा y axis को को पॉइंट रे काटी छी से काटी छी 0 आ a naught पॉइंट रे 8 एती गेला a naught that is y-intercept 8 एती 8 टू ए 0 रु एती गेला a naught ताले आमे जानि छे y axis रे x कोऑर्डिनेट कोन हो 0 x कोऑर्डिनेट आ 0 हला 8 एती केते ना a naught is the y intercept here so this point is a naught 0 a naught here slope equal to tan theta is equal to minus k so the coefficient of x is the slope y equal to mx plus c here slope is m in this equation here slope is minus k एठी x की है t x रो कोएफिशिएंट की होची minus k that is slope होची minus k here slope is minus k now we have to find the value of k here first we have to find kt and then we have to find k kt equal to a naught minus a here kt equal to from this equation Kt equal to a naught minus a. Implies k equal to a naught minus a by t. A naught minus a by t. K टा केते हिजबो ना a naught minus a by t. Here this equation, this is the equation 2 here. So we can write here the equation 2 represents the integrated rate equation for zero order reaction. This is the integrated rate equation for zero order reaction. We can also write the different terms involved here. Here a naught is the initial concentration of reactant, a is the final concentration of reactant, here t is the time, here k is the rate constant or velocity constant or specific reaction rate. We have to mention all the terms involving which are inside the equation 2. सब term को हमको explain करिया पड़े जोटा equation 2 रे अछि. So this is the final integrated rate equation for zero order kinetics, or we can say also it as the kinetics for zero order reaction. एटा को हमें kinetics कहि परिबा. zero order reaction पई हमें kinetics कहि परिबा, और zero order reaction पई एटा को integrated rate equation कहि परिबा. Now we have to find the half life period for zero order reactions. Next is half life period for zero order reaction. So what is half life period? The half life period is the time required for the reaction, the time required by the reaction for half of the completion is known as half life period. गोटे reaction अधा complete होबा पई जो time required हुए से time को हम कहउचे half life period. Suppose मु initially नेतिली 100 mol, मु reactant रो concentration केते नेतिली ना 100 mol per liter. मु नेतिली 100 mol per liter initial नेतिली जतले reaction start हेनला product पाइतिली 0. without time t equal to 0 रे मु नेतिली 100 mol per liter. Concentration केते थिला 100 mol per liter. Suppose a reaction is A gives rise to product, that is P. At time t equal to 0, the initial concentration of A is 100 mol per liter, and at time t equal to 0, the product concentration is 0. जेहेतु reaction start हेनी, product concentration होबनी, formation होबनी product, so concentration of product is found to be 0. At time t किछि भी हेइ पारे, हमें जानि नै टाइम t टा केते 1 सेकंड कि 2 सेकंड कि 2 आवर कि 3 आवर जानि. मो टाइम t रे मो पारली, सपोज टाइम t को मु नै गली at t equal to 15 minute at t equal to 15 minute, this 100 mol per liter decreases to 50 mol per liter. So the product concentration will be 100 minus 50, that is 50 mol per liter. So here the reaction is half completed. माने reaction एटी आधा सरी जाइछि. काहेकि ना 100 मोल नैथिले आमे 50 मोल पाइले आधा सरी गला. रिएक्टेंट रो कंसंट्रेशन 100 मोल नैथिले आधा सरी गला और आधा फॉर्मेशन हला. सो आमे कहि परिबा एटा रिएक्शन आधा सरी गला. टाइम केते नला ना 0 मिनिट, आमे 0 रु टाइम स्टार्ट करथिले पाइले केते 15 मिनिट. ताले हियर the 15 minute is the half life period and it is denoted by t half. So t half here 15 minute. So we can define the half life period as the time required for half of the completion of the reaction is called half life period, or we can say the time required for decrease of half of the concentration of reactant is called half life period, or we can say the time required for the formation of half of the concentration of the product is called half life period, or we can also write the time required for half of the time required for the conversion of half of the concentration of the reactant to product is also called half life periods. So first we have to write the definition, then we have to proceed. So simply the time required for half of the completion of reaction is known as half life period. Suppose the chemical reaction is A gives rise to product at T equal to 0. The concentration of A is A naught. At T equal to T half, subscript a 1 by 2 ta subscript T into 1 by 2 no, that is subscript T half. At T equal to T half, A naught equal to थिला केते A थिला A टा ए naught र अधा रहिथिबो हम जदि 100 मोल नै थिबा A naught एटा 50 मोल होबो. So the final concentration will be the half of initial concentration. So this will become A naught by 2. Here at time 0 product 0, at time T half नै थिले A naught remaining अछि A naught by 2. So एटा हिजो A naught minus A naught by 2. A naught minus A naught by 2, that is equal to A naught by 2. A naught minus A naught by 2 is A naught by 2. Now we have to derive the half life period for zero order reactions. The derivation is we know from the zero order kinetics, we know the integrated rate equation for zero order kinetics is K equal to A naught minus A by T, whole divided by T. So we can write here, according to zero order kinetics, K equal to A naught minus A by T. Here we have to put T half instead of T. हमें T पाई हमें T half put करिबा. तापरे A naught minus A पाई हमें put करिया A naught by 2. तो एटा को एमिति लिखि परिबा हमें. एटा हम एई बडे लिखि परिबा. एक सेकेंड. एटा को हमें एई बडे लिखि परिबा. आगरो थिला एटा केते हमर A naught minus A थिला. A naught minus A थिला. एटा थिला आगरो. एटी थिला A naught, एटा नथिला A naught थिला एटी A थिला. एटी थिला A naught minus A. Here A will become A naught by 2. अधा सरी जाईची. So A naught minus A will become, आमे A पई कोन पुट करिवा, A पई पुट करिया A naught by 2. ताले A naught minus A naught by 2 केते हिजो A naught by 2. एटा अछि A naught minus A, एटा अछि A equal to A naught by 2. A equal to A naught by 2 अछि. एटा अछि A naught minus A अछि. हमें ए पई A naught by 2 पुट करि परिबा. A naught minus A अछि. So A पई कोन पुट करिया A naught by 2. ताले A naught minus A naught by 2 केता हो A naught by 2. So K equal to A naught minus A रो वैल्यू होची A naught by 2. A naught by 2 whole divided by T पई पके परिबा T half. So हमहु फाइंड करिया अछि हाफ लाइफ पीरियड. हमें T half फाइंड करिबा. एटा है जो K equal to A naught by 2 T half है जो A naught upon 2 T half. So here T half equal to A naught by 2K. T half equal to A naught by 2K. This is the expression for, this is equation 3. Here equation 3 represents the expression for half-life period for zero order reaction. Here equation 3 represents the expression for half-life period for zero order reactions. So we have to write the characteristics. We have to write the characteristics for zero order reactions. Now let me discuss the characteristics for zero order reactions. Characteristics for zero order reactions. Zero order reaction. So what are the characteristics? First characteristics is that in zero order reaction the rate of reaction is independent upon concentration of reactant. First we have to write rate of reaction ROR. Rate of reaction doesn't depends upon the concentration of reactant. The concentration of reactant. ताले कहूची से रेट ता कंसंट्रेशन ऊपर डिपेंड करूनी ता अर्थ आमे कंसंट्रेशन जते बढ़ाइबा तथापि कि रेट ऑफ रिएक्शन ऊपर कोनोसी फरक पड़िबोनी यदि कंसंट्रेशन को भी कमे दबा रेट ऑफ रिएक्शन ऊपर भी कोनोसी फरक पड़िबोनी द रेट ऑफ रिएक्शन विल रिमेन सेम थ्रू आउट द कोर्स ऑफ रिएक्शन रिएक्शन जे पर्यंत चालू रहिबो रेट ऑफ रिएक्शन से पर्यंत कांस्टेंट रहिबो इन जीरो ऑर्डर रिएक्शंस आमे ग्राफिकली केमति रिप्रेजेंट करिबा नाउ वी हैव टू प्लॉट द ग्राफ रेट वर्सेस कंसंट्रेशन. Here is rate of the reactions. Here is concentration. Here is concentration. Here is rate. Here is concentration. Concentration suppose 0 थिला. Concentration तो 0 होबनी केबे भी. Concentration केबे भी 0 होबनी. जेतले concentration पैरेलल हो रेट ता पैरेलल हो कंसंट्रेशन एति की थिला रेट एति की थिला कंसंट्रेशन केबे 0 होबनी कंसंट्रेशन ऑफ रिएक्टेंट शुड नेवर बी 0 काहे ना रिएक्टेंट रो कंसंट्रेशन केबे भी 0 नै बेरे जदि रेट ता डिपेंड करूनी कंसंट्रेशन सहित नेचर ऑफ द ग्राफ कोन हो पैरेलल हे जिवो कंसंट्रेशन तमे जहां भी चेंज करो कंसंट्रेशन rate of the reaction always remains same. मानकर maximum concentration एति की थिला rate पाइथिले एति की तले ग्राफ ता केते 0.8 पाइले concentration आउट के कमेले एति की कमी rate ता constant रहबो. So the nature of rate concentration of graph is parallel to the concentration axis. This is the nature. Next point is हाफ लाइफ पीरियड हम जानि छै हाफ लाइफ पीरियड टी हाफ रो फार्मूला जानि छै a नॉट बाय 2k हम जानि थिले बे पढिथिले टी हाफ टा हम पढिथिले केते a नॉट बाय 2k so your half life period directly proportional to initial concentration. It clearly हमें जानि परछे this equation indicates that the half life period is directly proportional to the initial concentration. If you increase the initial concentration then half life period increases. If you decrease the initial concentration then half life period decreases. So Second point is the half-life period. Half-life period is directly proportional to the concentration of reactant, initial concentration of reactant that is T half equal to A naught by 2K implies T half directly proportional to A naught. So the nature of graph will be T half concentration A naught nelle concentration of A naught nelle. Here T half is directly proportional to A naught. So nature of graph will be a straight line starting from the origin. The nature of graph will be like this. Next point is, since it is a zero order reaction, it always obeys zero order kinetics. Since it is a zero order reaction, it always obeys zero order kinetics. That is the third point in the characteristics. It always obeys the zero order kinetics, that is सबले zero order kinetics को उबे करो, that is A equation को सबले उबे करो, K equal to A naught minus A by T. Equation को सबले उबे करो because it is a zero order reaction, so obviously it obey zero order kinetics. Next is the last characteristics is for zero order reaction the unit of rate of reaction, that is ROR. The unit of rate of reaction is equal to unit of rate constant, that is K. The unit of rate of reaction is equal to rate constant is equal to unit of rate of reactions, that is rate of reaction ର unit ଟା rate constant ର unit ସହିତ same ହବ. ସେଟା कोन हबो को unit ना mole liter inverse second inverse. This is the unit of ROR and unit of rate constant for zero order reaction as well. हमें जानि छे एटा rate of reaction ର unit से जे कोनोसी reaction हो rate of reaction ର unit सब बेले mole liter inverse second inverse. किंतु zero order reaction रे rate of reaction ର unit तो mole liter inverse second inverse हबो, किंतु rate constant ର unit भी mole liter inverse second inverse हबो. Only for zero order reaction the unit of rate constant will become the unit of rate of reaction, that is mole liter inverse second inverse. This is all about the zero order integrated rate equation for zero order reaction and half-life and characteristics of zero order reaction. In the next lecture we will discuss some questions regarding rate expressions. So this lecture, today lecture is completed here. So thank you all the best.